Thanks, everyone. So today what we're going to look at is Sirovision. So we're going to go through kind of just a basic general of Sirovision, and then we have come out with a new release of Sirovision, so we're going to be going over the new functionality inside of that. Basically, we're going to be covering, the main topic of today's webinar will be covering georeferencing of images, so we're going to focus on that mostly. If you have any other questions about Sirovision in general, though, please feel free to ask them at the end of the conversation, and if they require a little bit more explanation, we will be happy to follow up with you offline. So to start, we're going to go over just a few slides on what is Sirovision, where it came from, the agreements we have with it, and then we will be hopping directly into the software to show how to do the georeferencing. So we're basically just, the presentation is going to cover kind of what is Sirovision, how it works, how it implements, and how you, the user, can take advantage of it. So originally developed by the Commonwealth Scientific and Industrial Research Organization, or CSIRO, it was acquired by Datamine 5 years ago or so, and since then we have been the main distributor of it globally. Originally developed in the Newcrest Tesla mine, it is a unique set of opportunities to take and gather geological data with ease. So we've been steadily growing with globally since 2011. It's currently used in Australia, China, Africa, and North America. And you can see some of the big companies that are currently our clients using this product. So when using Sirovision, some of the main things is that it helps improve safety, and I'll show you some examples of that, and productivity within your mine site. So those are the two main features, is that we can use Sirovision to safely and accurately gather information and look at it on surface rather than spending a lot of time looking at active faces. And the acquisition of the data is very easy. So the productivity becomes better as you use Sirovision. So the way Sirovision works is that it generates a scaled 3D image of rock face from stereo photographs taken of open pit and underground environments. And then from there, we can do a series of geotechnical and geological analysis. Who uses them? Well, pretty much most of the technical people at a mine site will use them, so mining engineers, geotechnical engineers, and geologists. So first part is there's two parts to Sirovision. One is called Sirovision. It's the same software, but you can use it for an underground environment or an open pit environment. So when you're looking at an underground environment, how does it work? It uses the specially designed Datamine stereo camera. It creates a 3D model of the real world. You can then georeference the spatial data. And then because it's georeferenced, all the mapping is actually in real space. So you get an accurate representation of the contacts and the actual locations of the contacts and structures right on your image. This is an example of what the stereo camera looks like. It's this orange box here in this image. And you can see here in this one that it has evolved a lot in the last 10 years. So the original prototype literally was this plexiglass steel container you see on the left. And now what we have is sort of been evolved to what you see on the right. So in the current model, we have two 16 megapixel digital SLR cameras. We have a touch button to take the image, touch screen so you can set up parameters, lighting, different effects types of things. And then we have the ability to either download via an Ethernet cable or a USB connection. It's light enough that one person can carry it. I think it's somewhere between 11 and 13 kilograms. And with the backpack provided, it's actually not that bad. And the nice thing is that the batteries are very, very good. They are long lasting, and you can take many pictures with it on one battery charge. So what is Sirovision Open Pit? Well, Open Pit uses off-the-shelf digital SLR cameras to do the same thing in an open pit scenario. So we get the same sort of capabilities of capturing an open pit image, just like we captured the underground image, but now we don't need to get a special camera. We can just use digital SLR cameras. What we do is we set up cameras to be as perpendicular to the face as possible, and we need to set up a left and a right camera image. Now, typically the ratio between the distance between the cameras and the distance of the face is somewhere between 6:1 or 7:1. And you can see that in this example that we have 60 meters to the face and 10 meters between our camera. From there, we can create, again, a scaled, accurate digital image. From there, we can do multiple images stitched together. So you can imagine yourself getting a large-scale 3D mosaic of your open pit. And then from there, using simply just 3 points with known GPS coordinates on your one image, you can actually georeference numerous images. So why should we use a mapping system like this? Well, in an underground scenario, the system has a range of about 3 to 12 meters. So what that means is that if you're looking at an average 4-meter round, you can actually stand well back of the 4-meter round. Maybe the round is still exposed, and you can get accurate image and mapping information from the images without actually having to put yourself in the line of danger or wait for someone else to come in there and scale it and screen it for you. In an open pit scenario, the range is actually a lot larger. You can see that we have a range of 5 to 1,500 meters, and we can actually be standing at the top of the pit taking pictures down. So you can see that it actually takes us away from where all the activity is, so we don't have to be necessarily directly in the line of fire of big haul trucks, of big mining equipment, and slope failures. Once the image has been accurately georeferenced, it allows us to get an accurate calculation of structures on our face. Because of the georeferencing, this mathematics is now objective, not subjective. So there's a lot less measurement bias. So our spatial accuracy is somewhere around less than 3 centimeters, and our angular accuracy is usually within a half a degree. And the nice thing is that it's fast. So if we look at just a simple sort of scenario where we have drill, charge, fire, we vent out the gas, we muck it out, we scale it, and then we can take some pictures. So we fit right into the existing mining cycle. And when we say that it's fast, my experience and my habits underground is usually I can take a series of pictures of a heading, 4 to 6 images of a heading, less than 5 minutes. So it means that you're really not disrupting the actual flow of the mining cycle. And the software is actually very easy to use. Our training is usually 2 to 3 days. And the software, since the first iteration of it with Datamine, has become increasingly simplified and automated. It means that there's a lot of wizards built into it to get your processes completed very easily. That 2 to 3 days often takes into consideration a lot of time actually taking pictures, not just time in the classroom either. So it's really a good hands-on 2 to 3 days of training that gets you up and running and makes it so that when we leave, you guys are ready to go without any lack of information. And obviously, you actually have a physical record of what the heading was. So when the heading is now moved on, you slash the walls away, you've gone to the next face, you now have physical documentation of what that face was for any sort of questions on orientation of the ore or questions on structure. You can look back at the image rather than guessing on what might have been there. And relatively low cost setup compared to some of the other products out there that involve a lot of point cloud that doesn't actually get you any sort of photograph along with it. Now, what can it be used for? We can use it for mapping geological boundaries, lithological boundaries, mineral veins, rock mass features. We can do structures. We can define what we call schemas, so basically defining the different classification of structures. So you can look at joints versus faults, or joints at 1 versus joints at 2, those kinds of things. Once we map a structure on the face, and the face is actually georeferenced properly, we get an actual orientation of the structure. So it's no longer an apparent, it's a true dip. And then we have good wedge detection systems to look at potential hazards within the deposit. And this works both the same for open pit and underground. There's no difference between the availability of these sort of tools. Now, how does it affect our impact on mapping? Well, normally what we have to do is we have to go to the mine, map the structure, transfer the data to paper, we compile the final structure map, we then draft it in another software, and then we have to import it into our modeling software, for example. With Sirovision, we just go there, we grab the model, we take our pictures, we come to surface, we create the 3D image, we map them right on there, and then they're ready to go. That's all the slides I have for you. I hope everybody is ready to go because we're going to be hopping right into the software. First thing we're going to look at is, or the main thing we're going to look at today is georeferencing. So the new thing inside of Sirovision 6.1 is Crosshair's georeferencing used in an underground scenario. We're going to go over that in a little bit, but just to remind everybody of how it works, I'm going to go through sort of the current methodology, and then I'm going to show you how it differs for the new method or a new option available for you. So what you see on the screen here is just a simple one image. I've created a 3D image of it. It is just an open pit face. And you can see down here in the bottom right-hand corner, I've got 3 survey markers that were picked up, 1, 2, and 3. And I have imported a survey file. And the survey file just has simple 1, 2, and 3 different points available to me. I can open it up in a table. And you can see that it's very just simple name of 1 and the easting, northing, and the elevation here. So you can see it's just a very simple table you import, nothing fancy. It doesn't have, it has a specific format, but the format is very simple. And once that is imported, we can georeference this image either by right-clicking on it and go to Georeference, or we can right-click up here and Georeference as well. So we're going to click on the image, and we're going to go to Georeference. And as we talked about before, this process has now become automated. So I mean, not necessarily automated, sorry, but I mean, a wizard has been built that walks the user through all the steps necessary to georeference this image. Now, there's many different ways to georeference an image. What we like, the most inaccurate, even though it is still quite accurate method, is actually if you do not have access to put up points on a face or get a survey reading from some sort of survey team, you can actually use handheld GPS. So you can take an accurate handheld GPS, you can take an orientation with a compass, and all you'll need is the left camera position, the bearing, elevation, and tilt of the camera, and either the distance between cameras or the distance to the face. Now, this methodology is obviously the least accurate because your accuracy of your camera location is only as accurate as your GPS product. As technology evolves, that becomes a lot more precise. But a few years ago, there was a lot more inaccuracy built into these things. Otherwise, we can reposition using a minimum of 3 ground control points, which is what the survey file has. Now, it needs a minimum of 3. By no means is that a maximum. You can have 7 on the face. You can have 10. It doesn't really matter, as long as you have 3. The way our software often works is that you'll click on something, and it produces a scaled image and then another scaled image over here. So you can see that as I'm moving around, I get this box that appears to the right that zooms in on the area, and you can see that I come in here and I have 1, I have 2, and I have 3. So I've got little crosses built into the circles. And so all I'm going to do is I'm going to click on point number 1. And as soon as I click on point number 1, the wizard will tell me to select the exact location in the displayed image. So I come over here, click on the image, and as soon as I click on the image, you see that a bigger scaled position comes in which case I can just simply click in the image where I want the image to be centered on. So I'm going to center it on that point. And once I'm happy, all I have to do is click on number 2. So I click on number 2. I come over here to find point number 2. And again, readjust. So it's not critical that you get the first click correct. You can do as many adjustment clicks afterwards. And once it is happy with the location, you just come over here and you select the next set of survey points. So I'm going to take image number 3. Come over here and select number 3. Readjust. And now that I've entered in all my survey points, you see they appear on here. They have appeared in here. And then I hit next. And now it's going to show me a summary of what I've done. So based on the position of these 3 survey points, it shows me where the image is, where the camera locations were located, and the actual easting and northing and elevation of the deposit, of the images you took. If for some reason this looks out of place, like you have your images are offset, or if your cameras are way too far away, or if there's something that doesn't look right, you can always hit the little back arrow up here to go back a step, and maybe you've clicked on 1 and then selected point 4 when you meant to select point 1. So you can always go back and redo it at this step. Once you're satisfied with your georeferencing, push next, and then you'll see to close this wizard, click finish. And when I click finish, it's going to save the image and apply the georeferencing. And it doesn't take overly long, but it does have to apply this to the image. And you'll see that now on our left-hand side in our Project Explorer, the image now has a gray circle beside it, which I should have mentioned before I started was there's sort of a different set of circles to show what stage the image is in. If the image has just a quarter, it is not oriented, meaning that a 3D image hasn't been created. When the half circle is there, it's relatively oriented, meaning that you've created a 3D image, but you haven't associated it to any mosaic. Locally oriented is when the image has been assigned to a mosaic, but that mosaic is not georeferenced. And then once it's full, it is gray, and it means that that image is georeferenced and can be used when creating a mosaic, and will then georeference images beside it. That is all I have for the actual georeferencing of the old data. As you can see, it is very easy. It's very walkthrough, and it's very like we've been talking about. This automation process and these wizards have been in here to make the workflow very easily. I'm going to switch projects now to my next project, and you can see that in this one I actually have an underground image. So I wanted to show you guys both the underground and surface kind of capabilities, and you can see that this underground image, if you can see it quite right, we have a series of red dots, and this is the points on the crosshair level line. Now, I'm going to show you this image, which is this exact same face, and this is just the points labeled with where they are and how we're going to classify them. So you're going to need to set up an alignment laser. Let me just show you this here. Oh, wrong. Crosshair laser. So this is the tool that was used for the surveying. And so what you do is that it's just this box and it sets out a series of points. You just know yourself, your position of your tripod of this with your survey points. Use this, and then it'll georeference the face without actually having to go to the face to mark up survey points. I'm going to show you these before I go. So the way it works is that you have your heading, your main tunnel, an alignment laser projects dot on the back wall at a known bearing, dip, and distance, and then that gets projected to the face. You then have your vertical and horizontal crosshairs here, and using your location of the wall to the face and this, you can georeference the images very easily. And just to give you sort of an example of how fast this was, in the test that was done with this before it came into production, we were installing and turning on the alignment laser. It took 30 seconds. Setting up the crosshair lasers to align it to the same bearing as the alignment laser, 2 minutes and 30 seconds. Level the tilt, 1 minute. Take 4 to 6 stereo photographs, 1 minute. So our total time for this exercise with this new methodology, which is similar to the old methodology, is 4 minutes and 30 seconds. So again, we're not lying when we say you can get in and out of a heading in under 5 minutes. So what we need to do is when we go back into the software, we need to define these points as the horizontal line and the vertical line. And that's going to be done very easily. So this time when we right-click on it, you're going to notice that because we are in an underground scenario and we have this new methodology, we have the old way of doing georeferencing. And if we had brought in just a traditional survey file with 3 points on the face, we could use that like we did in the open pit scenario, or we choose this option of georeferencing using a leveled crosshair. We get another wizard, and so if we hit next, we need to manually input, so we need to put in the information, or we can do a survey file. If I go to here, you can see that this is the file that we're going to import. And you can see that, again, it has its own set of column names that you need to follow: easting, northern height, bearing, dip, slope, distance, and crosshair bearing. So these are the points we're going to use, and this is the information that's going to get imported into the software. Actually, I have to close this. So we're going to grab a survey file. I'm going to grab this survey file, and you can see it just brings everything in table format as we're used to. And I hit next. We now have the image that we have here. We have all the easting. So this is the tunnel laser position: easting, northern height, bearing, elevation, distance to face. The crosshair bearing is here. And you'll see that we need to define 3 things: the horizontal crosshair, the vertical crosshair, and the surveyed laser point. Now, if we go back to our reference image, you'll see that the alignment laser is that point right there. So that's the first thing we're going to reference. That's located right there. So we come up here. So this is to create the horizontal laser crosshair. This is the vertical crosshair. And this is the laser dot. So I'm going to click this, and I'm going to line this up here. And you can see that as I click in there, once again, I can come over here and I can readjust to make sure that everything is perfect, so I'm getting the best possible accuracy in my georeferencing. Now, you can either do the horizontal or the vertical. It doesn't really matter. We'll go through and do the vertical. And you can see that our vertical is way up here: V1, V2, V3, and V4. And because it's a crosshair, the placement of V3 is also the horizontal position of 2. So we have V1, V2, V3, and V4 located right there. They may be a little hard to see, but I hope you see them on the right-hand side when I zoom in. So that's V1, V2, V3, and V4. So what we do is we come up here, select the vertical laser crosshair, click on it. We click on the first one, readjust. Click on the second one, we readjust. Click on the third one. And you can see it's very easy. I'm just doing 4 points straight down that match up to the 4 points that was produced by the crosshair. And you can see once I've completed these 4, I've entered in enough points that the software recognizes that the vertical crosshair is sufficient for georeferencing, and so I get a little green check mark there. Now I need to enter in the horizontal crosshair, so I select the horizontal crosshair. And the first one is right there. So I go and I readjust. The second one lies on the vertical 3, so it's right there. The third one, sitting there. And the fourth one is right there. So you can see, now that I've entered in the 4 down, the 3 across, and the survey line, all these here line up, are ready to go. The next button is available to us now, and we can continue on and verify that the plane is accurate. Again, we get a survey record. so you can see, or a summary record, so you can see the two different blue spheres here, the vertical and the horizontal, the location of the image, the location of our camera setup, and all the information of what we have available to us is sitting over here as well. If we're happy with this, we hit next. Otherwise, again, if you've mislabeled some or misselected an object, you can always go back using this arrow in the top left-hand corner. Push next. To complete the wizard, we push finish. And again, it's applying the georeferencing to the image. And now you'll see we have the same gray circle over here, and if I were to load the image into the field of view, you can see that it is now sitting georeferenced in real-world location, whereas before it was sitting in a relatively oriented location on georeference. So now if I wanted to map on this, I'm confident that the structures and the geology contacts that I'm making are in real space and are accurate, that I can then take and bring into Studio and use for my interpretation. The last thing I'm going to show you is quickly talk about the tools for exporting. A couple of new things we've added to the exporting is the ability to export to different file types. So we have the ability to export our 3D image, our mapped objects, or our analysis set. If we click on mapped 3D image, you can see that now, in the past, we've had the ability to export to a TIFF, a PDF 3D, or a DXF. We can now export to a PLY and an OBJ, and these file formats are used in additional CAD and GIS software. So we're increasing the capabilities of Sirovision to take the data out of Sirovision and put them into other software. So it allows us to sort of make our tool a little bit more flexible when talking to clients, because we now have the ability to export to more options. As always, our images, when we bring them in, if you think that these images are taken with a 16 megapixel camera, they can be rather large. So we do have the ability to reduce the image factor. This will reduce sort of the resolution of the image, but since you've already mapped on the good resolution, your mapping sets will stay accurate. It's just the actual size of the image will reduce because the resolution of the image may be a little less. And that's all depending on you and how you want to save the image later. That's pretty much what I wanted to show you guys today. Thank you so much for joining us on this webinar. Just so you guys know that we have a great YouTube channel, and on our YouTube channel, our product owner John Godfrey has put out a couple of good videos recently. One of them is on merging image files, so that's really will be interesting for you guys to check out if you want to go check it out. I'm going to pass the floor back to Teresa to see if there were any questions came up during the presentation.
Thanks, Neil. So we'll begin the Q&A question. As mentioned, if you have questions for our presenter, please type them into the chat box on the screen. During the presentation, we got a couple questions, so let's start with those. Neil, can you reference mosaics or just images? Sorry, can you georeference mosaics or just images?
Absolutely. So the methodology I was showing today was just for time saving, is just referencing one image. There's a couple of ways you can do it. You can create a mosaic and then georeference a mosaic, or you can take one image, georeference it, and then when you create a mosaic from it, it will actually georeference the images associated with it. Usually, one georeferenced image can georeference accurately 3 images on either side. So you're looking at about 1 georeferenced image for every 7 images.
Okay. And is the crosshair method more accurate than the traditional method of georeferencing?
I don't think there's a difference in accuracy. I think it's more just accessibility. A lot of the time, surveyors in an underground scenario are very busy. They have a lot to do. And if you don't want to have to rely on them, you can use this methodology so you don't necessarily need to rely on a survey team to pick up the points on the face, especially if your mine site workflow involves a lot of shotcrete, because you could lose those points before you get a chance to georeference your image properly.
Okay. Well, thank you very much, Neil, and everyone who joined us today. We appreciate your time. We'll be following up with an email containing a link to this recording. If you have any questions or comments, you can reach me, Teresa, by email at teresa.bowers@dataminesoftware.com or by phone at 705-688-0101. That's it, everybody. We will see you in 2 weeks when we're going to do a webinar on scripting. Take care and have a great day.